Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the important concepts of binomial expansions with examples. And for this, I am using the work of an outstanding and one of my best student, Miss Bisma Sami of class 2021, the Lyceum. Equation to get an A star. Work according to this equation to get an A star in math. Comprehensive concepts plus regular practice is equal to A star. Binomial expansion of 1 plus x whole power n for values of n that are not positive integers. For example, the values of n are half, 1 upon 3, minus 2, minus half, minus 1. In P1, we learned that the binomial expansion of 1 plus x whole power n, where n is a positive integer, is this. This is the theorem we have done in P1. 1 plus nc1 x to the power 1, nc2 x to the power 2, and so on, where nc1 is n upon 1 factorial and nc2 is nn minus 1 upon 2 factorial, and so on. So by substituting the values of nc1 and nc2 into this theorem, we can get this theorem. nc1 is n upon 1 factorial, nc2 is nn minus 1 over 2 factorial. So we will use this theorem in P3. Well, the above general binomial theorem can be used for any rational values of n. For example, these values of n. And this theorem can only be used when n is positive integer. There are two very important differences when n is not a positive integer. These are: the series is infinite. The expansion is only valid for these values of x. Note, in P3, while using the binomial theorem, make sure that the first term is 1. If not, then make it 1 by taking common. Let's understand how to make the first term 1. Make the first term 1 in the following expansions. Number 1, take this 2 common very carefully. So when you will take 2 common, because we have to make this first term 1. When we'll take this 2 common, we'll get this thing 2 bracket 1 plus 3x upon 2 and whole power is minus 2. This is extremely important. This power is for both the terms, this 2 and this expansion. So take the common carefully, make sure the power is given to both of the terms. This is very important. This step is extremely important. Always use a square bracket after taking common. Then distribute this power to both the terms, to this 2 and this expansion. When you distribute this power to this 2 and this expansion, you will get this thing 2 power minus 2, 2 power minus 2. This 2 will become 2 power minus 2 and this expansion will become whole power minus 2. Now simplify this term very carefully. 2 power minus 2 will become 1 upon 2 square. It's here. And then it will become 1 upon 4. And leave this expansion as it is. Now you will need to expand this expansion. You won't expand this expansion in P3. You will expand this expansion because in P3, the first term of the expansion must be 1. And this is the way to make the first term 1. Another example. Again, we have to make this first term 1 by taking this 5 common. See, when you will take 5 common, then this expansion will become 1 upon 2x power 2x upon 5, because this term is not multiple of 5. So you need to divide this by 5. So 1 minus 2x upon 5 whole power minus 1. Two things are very important. Make sure you will take the common correctly, and then you will use a square bracket and write the whole power here. Now distribute this power very carefully. When you will give this power to 5, this will become 5 power minus 1, and this expansion will have power minus 1. This 5 power minus 1 will become 1 upon 5. This is the way to take common 5. It's better to take common when the expansion is in denominator. If expansion is in denominator, then take common in denominator and then bring the expansion in numerator. So when you will take 3 common from this expansion, you will get this thing. 1 minus x upon 3 whole power 3. Then it will become 3 cube 1 minus x upon 3 whole power 3. And finally it will become 27 1 minus x upon 3 whole power 3. See, this is here. Now you have to bring your expansion in numerator to expand this. Never bring coefficient in numerator, just bring the expansion in numerator. 4 upon 27 1 minus x upon 3 whole power minus 3. Now you will need to expand this expansion. Here this is 1 upon 3. 3x plus 8 whole power 1 upon 3. Now the first term should be 8. You have to take, you first need to arrange the expansion in ascending order. First expand the expansion in ascending order and then take 8 common from this expansion. So when you will take this 8 common, you will get 8 times 1 plus 3x upon 8 whole power 1 upon 3. This step is extremely important. Whenever you will take common, or as soon as you will take common, you should use a square bracket and then distribute this power to both the terms. This 8 power 1 upon 3 will become 2 cube 1 upon 3, and after the cancellation it will become 2. Now you have to expand this expansion. So this is the first step, common, and this step is extremely important. Usually students make mistakes in this step. Well, this is the theorem. If we have positive sign here, then this x must be positive. What if we have negative sign here? Then you have to write negative here. If we have negative sign here, then we will write negative here. And we will expand the theorem with positive signs. All signs are positive. And the second term has negative sign. Like in this case, the second term is negative 3x. So we will write minus 3x here, minus 3x here. Well, expand 1 minus 3x whole power minus 2 in ascending powers of x up to and including the term in x square. So we have to expand this expansion till the term x square, meaning the third term, till the third term. So according to this theorem, we have to write 1, then positive sign, then n. In this case, n is minus 2. So minus 2 upon 1 factorial. 1 factorial is 1, so you may write or you may leave it. And second term, the second term is minus 3x. So replace x by minus 3x. Now according to this theorem, n is minus 2, n minus 1 is minus 3 over 2 factorial, and the second term is minus 3x whole power 2. Now just simplify this carefully. That's the final answer. Now expression is valid for, I told you expression, binomial expansion. This theorem is only valid for these values. So by using this rule, we can get the values of x for which this expansion is valid. So the second term, just write second term here. The second term is minus 3x. So replace x by minus 3x. So you'll get minus 3x modulus less than 1. You know modulus converts negative into positive. Therefore you'll get 3 modulus x less than 1. Now get the values of modulus x. So modulus x is less than 1 upon 3. This is the way to get the values of x for which the given expansion is valid. Always use this rule. Example. State the range of values of x for which the following expression is valid. Again use this thing. X less than 1. So when you will replace x by 2x square, you'll get this thing. Now you have to work for modulus x. Now bring this to outside the modulus, divide this to here, and just take a square root on both sides. So when you'll take a square root on both sides, you'll get this thing. Modulus x is valid for less than 1 upon root 2 values. Expand 1 plus 2x whole power minus 3 in ascending powers of x up to and including the term in x square till the third term. So according to this theorem, we can easily expand this expansion. So the first term must be 1, then n, which is minus 3. Second term is 2x over 1 factorial. n minus 1 means minus 4. Second term 2x whole square upon 2 factorial. This is the simplified form. Now expression is valid for these values. Use this rule. Modulus x less than 1. Now if you will replace this x with the second term, which is 2x, you will get the values of x. Bring this to outside the modulus, divide this to here. So this expression is valid for these values of x. Expand this in ascending powers of x. So this expansion has power 1 upon 3, and fortunately the first term is 1. We don't need to take common anything. So according to that theorem, this theorem, we can easily expand this expansion. So 1 n second term over 1 factorial, and the second term is minus 6x. Whenever you use the theorem, always take the sign of second term. Always consider the sign of second term while using the theorem, and all signs must be positive. Now 1 upon 3, which is n minus 1 is minus 2 upon 3 over 2 factorial. Second term has power 2. n minus 1, n minus 2, second term to the power 3 over 3 factorial. Now just simplify this very carefully. Expression is valid for these values. Substitute this x by the second term, which is negative 6x. So you need to work for modulus x. Bring minus, this minus will become plus, and this 6 will come outside the modulus. Modulus converts negative into positive. So this expansion is valid for these values of x. This question is important because the first term is not 1. Here we will learn how to take the first term 1 in the question. Expand this in ascending powers of x. Ascending powers means like constant, then x, and an x square, from small power to highest power, large power you can say, till x square, and values of x for which expansion is valid. And this question is from past paper, June 2020, paper 31. Well, the first important thing is make this first term 1 by taking 2 common very carefully. So when you will take 2 common from this expansion, let me zoom in this. So when you will take this 2 common, this expansion will become 1 minus 3x upon 2. You have to divide this 3x by 2. And make sure you will use a square bracket. And this power should be here. And then distribute this power to both the terms, this to this 2 and this expansion. So this will become 2 power minus 2 and the expansion has power minus 2. Now this expansion is ready for the expansion. You can easily expand this expansion now with the help of the theorem. So this 2 power minus 2 is 1 upon 4 is here. Write 1 upon 4 here, use a square bracket, write the first term here, then n, according to the theorem n, which is minus 2 over 1 factorial. Take the sign of second term, minus 3x upon 2 power 1. Now this is n minus 1, which is minus 3 over 2 factorial, and second term with its sign, negative sign, and power 2. Now simplify this very carefully. And that's the final answer. Make sure you will multiply 1 upon 4 with the bracket. Now, values of x for which this expansion is valid. Always take the second term from here, from this expansion. Whenever you work for the values of x for which the expansion is valid, always use this expansion and write this term here. Replace this x by this second term. Your x is replaced by minus 3x upon 2 here. Now bring this minus will become plus, bring this 3 upon 2 outside the modulus and divide this 3 upon 2 here. So these are the values of x for which this expansion is valid. You can take this screenshot of the solution if you want. Well, partial fractions and binomial expansions. One of the most common reasons for splitting a fraction into partial fractions is so that binomial expansion can be applied. Two very important expressions for power minus 1, which are used in partial fractions only. So if the power of the expansion is minus 1, you can use this rule. And if the sign is plus. So when the sign is plus between the terms, when this sign is plus and power is minus 1, then this expansion can be expanded in this way. Can directly be expanded in this way. This is the direct expansion. And when we have negative sign here and power is minus 1, then we can directly expand this expansion in this way. See, when sign is plus and power is negative 1, make sure you will use these two expansions only for power minus 1. If power is anything else, then always use the factorial form of the theorem. Never use these two results. So when we have positive sign here, and the first term must be 1. If the first term is not 1, then you can never use any expansion of binomial. First you have to make the first term 1 and then you can use these rules. So when we have positive sign between the terms and power is minus 1, then we expand the expansion with alternative signs. See, the signs are alternative: minus, plus, minus, plus, minus, and so on. So you can learn this rule in this way. The power is negative 1, the power must be negative 1, and sign is positive. So you can expand this expansion in this way. 1, then signs are alternative, minus, then second term with power 1, plus sign, second term power 2, and don't consider the sign of second term. Always write second term without its sign. Just write x. Like in this case, the second term has negative sign. Just ignore the sign of second term. Just write the expansion in this form. 1, then plus, all signs are plus, and second term is without its sign. The sign of second term is negative, but since this is the final answer, so we just write second term without its sign. x, x, then x power 2, x power 3, x power 4, and so on. You can learn how to use these expressions with these examples. With the help of these examples, you can learn the application of these two results. So applications and examples. 1 plus 3x upon 2 power minus 1. This is similar to this. See, the sign is positive and power is negative 1. And the second term is 3x upon 2. So you will write 3x upon 2 here, here, and here. So 1, signs are alternative, minus second term sign 1. Second term with power 1, then second term with power 2, and then second term with power 3, and so on. And just simplify this. Now, this is the example of this rule, of this expansion. See, the sign is negative and the power is minus 1. So we have to expand all the terms with positive signs. All signs are positive. So 1 plus 3x upon 2. Second term is 3x upon 2. Write the second term without its sign. So 3x upon 2, just ignore this negative. 3x upon 2 power 1, 3x upon 2 power 2, 3x upon 2 power 3, and simplify this carefully. So these are the two, you can say, applications or examples of these two rules. Partial fraction questions. Well, we already have done partial fractions, so you all know how to expand this, how to split this fraction into partial fractions. So I'm not discussing how to express this in partial fractions. So we have this result. This is the partial fraction of this fraction. Now the question is expand p of x, this p of x, up to and including the term in x square. Now you have to expand this carefully. Number one, check the first term of the expansions. This expansion has first term 1, so this is fine. But this expansion has first term 2, so we have to make the first term of this expansion 1 by taking 2 common. See, when you will take 2 common from here, from this expansion, you'll get this thing. 6, 1 plus x square upon 2. Let me do this here. 2, 1 plus x square upon 2 whole power 1. So this will become 6, 1 plus x square upon 2. It's here. Well, we never expand the expansions in denominator. We always bring the expansions in numerator and then we expand the expansions. So first bring this expansion in numerator and this one is also. So bring both the expansions in numerator. So this is 2 upon 3, 1 minus x whole power minus 1. This is 1 upon 6. Copy this as here, 2x minus 1 as it is. Now bring this in numerator. When you will bring this in numerator, this expansion will become this 1 plus x square upon 2 whole power minus 1. Because its power is 1, when you will bring this in numerator, this power will become minus 1. Now you have to expand this with the help of this rule, these rules. See, we have negative signs, so we have to expand all the terms with positive signs. All signs are positive. And the second term is x, so x power 1, x power 2. Now here the second term is x square upon 2 and sign is positive, so we have to expand this expansion with alternate signs. So 1 is here, minus, second term is x square upon 2 power 1, then plus sign and power 2. We have to expand till x square. Now simplify this result very carefully. So you'll get this thing, 2 upon 3, 2 upon 3x, 2 upon 3x square. First multiply 2x minus 1 with these two. Don't multiply 2x with this term, because when you will multiply 2x with this term, this will become 2x power 5, which is not required. We need till x square. So you need to multiply 2x with this and 1 with these two terms. So 2x multiplied by 1 is 2x minus 1 is minus 1, minus 1 times this is x square upon 2. Now simplify this thing and give your answer in ascending powers of x. Now the next question, in fact the last example, we have to expand this. This is very important because this power is not 1. Here we will use the result of minus 1 here, and here we will use the factorial form because the power is not 1. I mean, the power will not be minus 1 in numerator. Now expand p of x up to and including the term in x square. First, simplify this. I mean, make the first term 1. When you will take 2 common, you will get this thing. So the simplified form of this is here. Now bring all the expansions in numerator. When you will bring all the expansion in numerator, you will get this thing. 1 plus x whole power minus 1, 2. This will become 1 plus x whole power minus 2, minus 3, and this result is here. Just copy this here. We can expand this expansion with the help of the rule of minus 1 power. So here is the expansion. 1 minus x plus x square. We can also expand this expansion with the help of the minus 1 power rule, which is here. Expand the expansion with alternate signs. And here you have to use the theorem because this power is not minus 1. 1 n is minus 2 over 1 factorial x to the power 1. Then minus 2, which is n minus 1 over 2 factorial x to the power 2. So we use the minus 1 power, minus 1 expansion rule is here and here. And we expanded this with the help of the factorial form, the theorem. Now simplify this carefully and get this answer. Advice: do maximum number of questions of partial fractions and binomial expansion to be very good at this topic. Well, practice is compulsory. I mean, if you want to be good at math, you must practice as much as possible. I hope this lecture will help you to understand how to expand the binomial expansions and how to use binomial expansions and partial fractions. An important advice for me and for everyone: be well mannered. We should be well mannered. Good luck. Allah Hafiz.